Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mask code at this side. In this video we are going to discuss the question mirror reflection, which is 858 question of LEETCODE. And the question says, let me discuss the question directly with you without reading it out. The question says that there is a square room. There is a square room, right? The length of the side of the square is P. It is given to you as P. Now, the corners, this corner has an edge of 2. This corner has the ID of 1. This corner has a edge of 0. And this corner has no ID, right? All the three corners does actually have a receptor attached to them. That is, this is receptor 0, this is receptor 1, this is receptor 2, right? The sides of the square are actually walls, right? Now the question says, suppose that if you throw a light from this particular corner, right? And it touches this wall at a distance q from 0, right? You will have to tell me which receptor will it intercept with. The question is, which receptor will it go into, right? Remember, these are the mirrors, right? The right light will just reflect off it, right? You are provided with the input p and q. So I've taken a typical example of p equals to 4 and q equals to 3, and if you will solve this question, you will get the concept of how to do this, how to approach the problem. So let us make a proper dimension square with p equals to 4 and q equals to 3, right? So I will treat one unit as 1. So I will make a square of size p equals to 4. So suppose 1, 2, 3, 4. Similarly, 1, 2, 3, 4. Similarly, 1, this will be equal, so 2, this will be equal, so 3, and this will be equal, so 4, right? And these are also equal, so 1 segment, 2 segment, 3 segment, 4 segment, right? So this, here it is 2, here it is 1, here it is 0, right? This is a square of size p equals to 4. All the sides are of size equals to p. Now the question says, but if q equals to 3, that means my ray is starting from here and it meets here, because the distance of distance of the first intersection with 0 is given to me as q. So my ray is something like this. This is distance 3, 1, 2, 3, right? And this is all distance is 4, right? Now, if I try to track its path, you know about the incidence ray, that the angle of incidence and angle of reflection are same, right? So if I try to draw an angle, etc., I know this triangle, and if I try to make the reflection 1, it will go something like this. If I try to extend this side, then this triangle, which is the upper right angle triangle, and the lower right angle triangle are actually congruent. I don't need to prove this. You have already studied this in the time of J in the reflection properties, right? Okay. Now, if they are congruent, then this side, which has a length of 3, is or equals to this side, which has a length of 3, right? Now, because the square is not of this side, this will get reflected here, and because this is side 3, it remains is 2. Because this is 1, it remains is 2. So it will actually come up here. This is my path. It will actually intersect here, and after intersecting from here, it will again cover the distance of 3. So after covering 1 and 2, it will get attached to this one. And after attached to this one, this will again distance a 3 in the opposite direction, that is this direction, and 3 from here will actually lead me to this corner, which contains the ID of 2, and hence my answer will be 2. The important things to note here were the reflection property, that is, it will actually cover the distance of q equals to 3 always. So q, 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 etc., right? And it will keep alternating its wall. It will keep alternating its wall. What do I mean by that? If I mention this as wall 0, I mention this as wall 1, you can see the first fully extended ray is meeting the wall at 1, then fully extended ray is meeting the wall at 2, and then it will then 0, then it will go for 1, for 0, for 1, for 0, etc., so on and so forth, right? The So if we will mention it, it is vertically traversing q units each time. Q units each time. This is the first observation. Second observation is wall is wall is getting switched again and again, switched alternately, right? Alternatively. Please, please focus on the results, right? Third is it is going upwards. It is going upwards if it goes out of bound. If it goes out of bounds, going up, going up. It traverses. It starts moving downwards. It starts moving down, and vice versa for downwards. If it is going downwards, it will reflect upwards. If it will reflect through upwards. What I mean by that is it is going upwards, it is again going upwards, but because of this it will start going downwards. It will start going downwards, right? Now my problem will get very easy if I try to make this everything. So I already have q, I want to get the vertical point. I want to get the vertical point. So that will I will take a position variable for it. Wall, I will take a wall variable for it, and it is going upwards or downwards. For the upwards or downward tracking motion, I will say operation, right? If it is going upwards, operation will be 1. If it is going downwards, operation will be -1. These are the two things. If it is at wall 0, this is wall 0 and this is wall 1. If it is wall 0, the wall will be 0. Wall 1 will be 1. Position is actually the coordinates. Now, what is the range of position? Because the length of the side is p 0. So if I assign the coordinates, it is at 0, it is 1, it is 2, it is 3, it is 4. So position is actually lying between 0 to p, 0 to p, both inclusive, 0 to p. Right now, I have to derive some more results. What are the results? I am saying that 0, it will get to 0 if my wall is 1, and position is 0. Similarly, it will get to 1 if my wall is 1 and my position is p. And for 2, it is 0 wall and position p. Right? Whenever I encounter anything, position p, wall 0, right? If I encounter anything like p0, p1 or 0 1 combination, I will say that is my answer. I will say that is my answer. So let us see how will we start. Let us see how will we start. So I will say initially my position equals to 0 because I'm starting from bottom left. My wall is also 0 because it is at the left wall, right? I'm going upwards right now, so op is equals to +1. Now I will say while true. I don't know how many operations it will take, but the question guarantees me that it will fall into one of the receptor. What will I do? I will say that position plus equals to operation multiplied by q. If operation is +1, it will increment my position directing that I am going up. If the operation is negative, it will decrement my position directing that I am going down. Right? This statement is actually ending my position. Now, if my position is greater than p, that means I have gone out of bounds in the upper mode. In the upper mode, then what is happening? What was happening is this is my position p, this is my position p, right? Suppose I hit here, it was 3 here, and this was whole length of 4, right? So if I hit here and I go here, so I have to come here at this distance is 2, right? This distance is 2. We already discussed it above. What is happening is I'm changing my operation. My operation is getting towards downward. So I will say if position is greater than p, what will happen? If position is greater than p, my operation will now become -1, right? My operation will now become -1. That is first thing. Second thing, what will happen is this was 3, right? This was 3. This was 3. The position is now, if you see, this is 4. Position is now 3 plus 3, that is 6. 3 plus 3, that is 6. I am actually 2 above my p. So if I say my difference is equals to position minus p, and what is this value? This is p minus difference. So I will say position will now get updated to p minus difference. Right? These are the few things I have to take care of. If that is not the case, okay, a particular case can be if position is less than 0. If position is less than 0, that is, it has gone down. Now if it has gone down, it is definitely traversing downwards, so I will change it to 1. Difference will be, now because it is 0 is the upper limit and position is here, so difference will be 0 minus position, and new position will be 0 plus difference. 0 plus difference, right? 0 plus difference. No problem in that, in understanding that, right? No problem in understanding that, right? Any of the operation works, any of the I will put an else if here, any of the operation works, my wall will be not equals to wall. If it is 0, convert it to 1. If it is 1, convert it to 0. Now after this all operation end, here comes my judgment call. If my wall is equals to 0, is equals to 0, in the 0th wall I had 2 here. If position equals to p, return 2, return 2. Otherwise, if else, I will say wall equals to 1. If position equals to p, the case was for 1, and if position equals to 0, the case was for 0, right? This is my whole code. This is my whole code. I just have to run it. I just have to run it. Okay, let us try to compile and run it. So here we are, guys. So before starting with the code, I would like to request you to please subscribe to my channel and hit the like button, because it really motivates me, right? And let us try to write the code down. So int position equals to 0, because we are starting with 0 as a vertical distance. My wall is also 0 right now. But my operation is 1, because I'm going upwards. Now I will say while true. What will happen while true? I will say first I will increment my position. So position will be equals to operation multiplied by q, right? Now if my position has gone upper bounds, in that case I will first calculate my difference, which is equals to pos minus p, and then my position is actually now equals to p minus difference. Because I was going upwards, that is why I got the upper bounds of upper one, and that is why I will say my OP is now equals to minus 1. My operation is now equals to minus 1, right? These are the three things I have to take care of. Second thing, else if my position is less than 0, right? That means I was going down and I go lower bounds. So again, in difference equals to 0 minus POS now. Now my position gets replaced to 0 plus difference. And now OP changes to 1. OP changes to 1. In both the operations, my wall will get negated, right? I don't care about them. And I will just add the cases for my checking, if it has fallen into one of the receptors or not. So if my position equals to P, and my wall is equals to 0, in that case, return 2. Else if my position equals to P, but my wall is equals to 1, in that case return 1, because my receptor 1 is present there. Else if my position is equals to 0 and my wall is equals to what do we say, 1, right? Return 0, right? Just as a safety I'm saying return 0. That will not happen anytime, but LeetCode says that if you have started a function, then you have to return a value, right? Let us try to compile and run it. Hope it will run fine and you will get your answers. There has been some difference. Position is 0 plus it will be 0 plus difference. Let us try to compile and run it now. Hope it will run fine. In the meantime, please consider subscribing to my channel. There has been a mistake again. It will be equals to, double equals to will come here. Small typing mistakes makes here bad code, I guess. So sorry for that. It is running fine. Let us try to submit it for the backend test cases as well. It is running fine. Thank you for watching. Have a nice day, and we'll meet tomorrow with a new question, new energy. Thank you. Have a nice day.